All right, we cool? Yeah, we're cool. Okay. Hour and 20-ish left this time. Oh, actually, I forgot. So that was an hour and a half of rehashing and learning new shit. Now, to go to Perplexity and answer questions on current shit. So this is going to be making your search statements more descriptive. Cool, we can use the AND operator. All right, here, now we're going to Perplexity. I can use this as extra research at the end. I don't need that now. I don't want to look things up. So, we're going to do please generate a quiz using all chapters up through 9 from learncpp.com. Excuse me, to awesome grasp of everything. All of it. These chapters. I'll update this thread in the future when I'm on another chapter. Okay. Yo. These are only short answers. What the fuck? Or how about I'll do this, but then the right prompt should be like test me on it so that I actually have to implement the things. All right. Bro, what? Oh god. Oh, it's GG. Okay. And what? The answers are here at the end? Okay. It is a purely procedural programming language. Procedural? Procedural makes me think like stuff that we run and don't look at, or procedural. Procedural programming language. I mean, it makes me think no with how this is phrased, but what is a procedural programming language? Fuck, I have no clue. Let me think. It's governed by a set of rules, syntax, just like any language. Procedural? I mean, it's it's a language that requires compilation. It's not an interpreted language. Well, yeah, it's not an interpreted language. I have no clue what a procedural programming language is. Two major paradigms? Like what? I don't know, object-oriented programming, which I haven't even touched yet with classes and whatnot. Statically strongly typed, meaning that the types of data cannot be changed dynamically. Oh, now it's fucking hot. I accidentally had the AC on 70 way too early. I fell asleep early yesterday or some day, and maybe it was Monday, and I put the AC like that, and then because I knew I was gonna fall, or I fell asleep, and then I woke back up, and I was like, yeah, I need to go back to bed because that's it. I can't recover from this. Like paradigm and feature are pretty synonymous in my mind, but I would think object-oriented language, but supported, so object-oriented programming, and what? I don't know what else there would be. Procedural? So something about the language itself. Procedural versus what? I don't know. file extension for source files, .cpp. Duh. Main function. Main is the function that is executed upon, it seems like it's the file that's ran upon running the program, the exe, executable, which is the, what do we call it, the translation units that are all linked up together. When we run that, main runs and pulls from all these other little pieces in other files. And once main ends, the program ends. So main is like a hub. Main is your flow, what's happening, what the program is doing. The order. Main is basically your whole program, seems like. From which other things are called. From which things defined elsewhere and declared within main via header files and therefore declarations / prototypes. So it actually runs the code. Main is where everything is called from. A valid variable name. We can't have space. We can't have... Yeah, I don't think they can start with a number, so that eliminates A. They definitely can't have a space in the name for D. And they also can't have a minus because it's going to say that the identifier value, so this identifier, this object, subtracted 2. So it's got to be B. It's like I want to respond. I'll do that and see how that goes. So 0 or 1. My guess is false, but I'm not sure what a procedural programming language is. All languages are defined by syntax, so it isn't that it's defined by procedures. It isn't that can access low level features and bit manipulation. Yeah, honestly, I'm just not sure what a procedural language is, dude. I don't know what that is. Paradigms? I'm not really sure. Paradigms? Features? Maybe. I haven't touched it yet, but object-oriented programming is statically and strongly typed. But that isn't a paradigm, I don't think. I don't know. The others are other languages. 4. Main is called upon running the program executable. Once it ends, the program ends. Everything defined in other CP files declared in main via or declarations is called from main. Main is like the brain of the brain? I don't know, like the executor of the program-ish. B, because can't start with number, can't have space, and can't have this operator minus because that's an operation. 6. Ints are whole numbers, integers, while doubles are floating points, values with decimals. Seven assigns 5. So right to left, I'm pretty sure this is 5 is assigned to B and B is assigned to A. I think true. Looks like, I think assignment, or true. I think assignment, is it associativity? Associativity or something is right to left. So we assign 5 to B, and then B to A. So 5 to both. Yes. No! Oh, you motherfucker! B. That's the remainder operator. It evaluates to the leftover value, or leftover integer value of the left operand divided by the right operand. 5 mod 4, or remainder 4, would be 1. 9. Need IO stream for the input and output stream objects, I think. I stream and O stream. We use the insertion operator for standard character output because we're inserting characters into the output buffer compared to extracting from the input buffer. So this, or oh, sorry. Yeah, so this. So operator that, not operator this, because that's extraction. 11. While loops do while loops execute their block at least once, then evaluate the condition to see if they should continue to determine further loops. While loops instead evaluate condition first, so they might not run their, not execute their block at all. 11. Break will execute a loop. Haven't seen exit nor stop, and continue just skips this loop iteration and goes to the next. Break will exit from the innermost loop. 12. No, there are non-value returning functions called void functions, so false. Yo? Function overloading? Haven't seen function overloading before. Bro, what? Oh, I think function overloading is when you have the same identifier for multiple functions, but the separate functions have different parameters. Is it the parameters? I think it's the parameters and the output type, but maybe it's the parameters. Different parameters. Different parameters, which means they are unique functions. Or at least an overloaded identifier, I think. 15. Yo? Okay, this is not the right one at all. Bro. Scope, duration, and linkage. Pausing on the rest because these chapters aren't right. Okay. That's why it's pulling from somewhere else. Curious though about this procedural shit and other things. It is not. It supports multiple paradigms. So procedural is C and it just has functions. Object oriented has classes. And then there's generic programming, which is templates. Interesting. So some languages might not have classes and objects, maybe? They might just be generic or procedural and generic. Interesting. And those are the different paradigms. Procedural, object-oriented, functional, object-based. Bro, what? Type systems, okay. Yeah. It's automatically executed when the program starts. It's the root. Cool. Can have them, but can't start and can't contain spaces or operators. Yep. Floating point. Yep, yep. Right to left. Associativity. Yep. 7 and 3 is 1. Cool. Because 3 goes in 2 times. Leftover is 1. Yep. Need it for output and input. Cool. Need the X insertion operator. Yep. For a while, we check it before. For a do while, we check it after. Yes, sir. For breaks, yep. Continue, skip. Exit. Oh, exit terminates the whole program. Really? Exit? The keyword exit? Really? Hit main. Exit? Man, that ain't no damn thing. That's standard exit, bro. Yep. Oh, okay, that's true. Yeah, it's the same name but different parameters. Okay. Well, you didn't need to change the return type here. You could have clarified it better by having everything be the same, but just having the types differ. Okay. Well, this is ass. So can do another quiz, please. No. Oh no. No. Just chapters through 9. Fuck. Or maybe this is okay. Okay. This actually might be alright. Oh fuck. Oh, I can find out. Yeah, this is cool. Nice. Nice. Okay. Compilers convert source code into binary, which is interpreted by the, or which is executed, read by the CPU. Interpreters, excuse me, don't compile and simply read the language without converting binary, i.e. no translation unit. And the processor, some are in the CPU, somehow executes. I don't really know how that works, because compiled languages, type it out, it's in source code, we compile it, it gets converted into binary, and everything's all linked up, converted to binary, we get our translation units, we're all cool, nice and packaged up. Boom, computer runs the binary. But interpreted, the computer is running something. Apparently there's no, it's compiled, it's either so it's either that or it is converted but live. So each statement is converted to binary live or some binary live, which the computer or CPU executes. I don't know. Main is automatically executed by the executable and calls everything in the program, or and begins the call stack. So it can call functions and reference and manipulate variables defined elsewhere. Yeah, header. Yeah, header by including header files for forward declarations. It basically runs the program, seems like. 3. Main. Something like that. 4. Function declarations. Simply tell the compiler that function X exists and is valid for this .cpp file. However, the linker must find a definition for the function and will yield a linker error otherwise. I.e., you include header files to include the forward declarations, so compiler knows that main.cpp can access those functions, variables that are defined elsewhere. Include header files to get access, or to include header files and include their code in your .cpp file. Same reason as previous. Okay, I'm gonna do this here because it's just easier. Main. Okay. Returns, printing the results. So we need iostream. Need standard character output. So we're gonna do a function named square that takes a parameter and returns its square. So we have int square. It takes an integer parameter, and we'll just say int num2 square. Return num2 square times num2 square. Square 4, or we'll do standard character output square 4. Boom. Cool. 6. What is a segmentation fault? Fuck, I forgot. What is a segmentation fault? See, we're trying to access memory that we haven't. No. Well. No. I don't know. What is a segmentation fault? Because at first I would think it's trying to access somewhere in memory that we haven't specified what's there, but that's not it. Like if I create a variable and then I return, or if I create a standard string and I return a string view in a function, and then main uses that value, it'll be looking at where that standard string was, but has already been destroyed because the function has already returned and destroyed that value. It's no longer there. A part of it might be there, but the variable should be destroyed because it's local. But the values might still be in that piece of memory. A segmentation fault? Fuck, man. Segmenting, splitting pieces, piecewise pieces of memory. Running out of memory, the call stack, no? Bugging in the call stack. Fuck, man. I don't know. I don't know. Segmentation fault. It isn't, it's just undefined behavior. I don't know. It isn't accessing memory. Well, I don't know. Okay, we have main, so we're going to say welcome. And welcome says greet, so it's going to say hello, and then it's going to say welcome. It's going to say hello, then welcome. Welcome executes greet to say hello, then welcome prints welcome. 9. Debugger. To come in debugger commands. Commands? For what? I use we can step into and over lines of code and function calls to watch local variables. examine execution flow. Commands? I ain't never typed no damn command, yo. I gotta sneeze. Fuck. Commands? Like what? Execute until or something? Like executing code until a specific point? Or jumping? Size of these types? We should be able to do... I don't know if I need a thing. Size? I don't know. Include input and output so we can get output. Oh, nice. Okay. Standard output int size of int int character bool double bool character. Four 118. Interesting. KO. Four 118. Doubles have greater precision than floats and are precise to a greater number of significant digits. Probably have more memory too, but can't say. I'd program that declares variables of each and prints their sizes. Oh. Okay. Character my character. Int my int. Bool my bool. Double my double. What is it? Each fundamental types we have integral values, characters, booleans, and integers, then doubles, and then whatever float my float, and then include IOStream because we need standard character output. And we could say standard character output, character, size of my character, standard character output, integer, size of my int, standard character output, bool, size of my bool, okay. Standard character output double, size of my double, and standard character output my float, size of my float. Oops. One four. Oh yeah, 14184. Interesting. Okay. Um, 13. I think a long. Is it L maybe? F for float. I think D for double. LL. Const expression or const over all literals. A const over better to have variables instead of literals to prevent magic to remove magic numbers where possible. More modular too, so we can update const expression or update const expression gravity, const expression int float gravity, and it'll update everywhere instead of having to change the literals. Change each instance of a literal. Defines a constant for the speed of light and prints it. Okay. Include stream. Need standard character output. Name. What was it asking? 3.3 times 10 to the 8th. 1, 2, 3, 4, yeah. That's hundreds, thousands, million. Yeah, we should be good. Should be accurate enough. Namespace, constants, concentration int, speed of light, speed of light equals constants speed of light. Bop. Prefix increment operator operates on the variable first, then the variable is evaluated. I.e., if x is 5 plus x, first updates 5 or x to 6, then evaluates to 6. X plus instead evaluates to 5, then increments to 6. Operator precedence of multiplication is higher than addition, therefore 3 times 2 is 6, plus 5 is 11. 18. Using the remainder, rather. Okay. Main. Return 0. Include string. Need standard character output. Int get remainder. This is int divider. Int divisor. divisor. I don't know which one is which, but whatever. Left and right. Return divider, remainder, divisor. Get remainder. Oops, standard character output. Get remainder. 5, 4, 3. Okay. 2. What if we said 5, 0? What happens? Boom. So say include C assert. Assert. What the fuck is this? Oh, I accidentally pressed 1. Assert divisor is not equal to 0. Oops. Oh, well, yeah, because we're gonna ignore, and we could say assert this, put this whole guy in the parentheses, and divisor is 0. Divide by 0, error. Oh. So what did it say? Oh, here it is. Assertion failed. Divisor 0 divided by 0. Nice. Good. Ignore. We say 3. Oops. Excuse me. Cool. Does it get them? Takes 2 ints. Cool. At 19. Local variables have local lifetime versus static lifetime, I think. Or static duration. So there's duration, there's lifetime, local lifetime, and are created upon definition, or definition and destroyed at the nearest close brace they were defined within, which is usually the end of the function, unless declared in an inner block, or defined in an inner block. 20. Static creates a local variable at runtime, or on program start. Value initial with a value or 0 or blank if a standard string. It's initialized only once when actually initialized in the function it's defined within. Its lifetime is static, or its duration is static, so it keeps its value and exists and persists between function calls. Static in x in a function that increments it if continually called will continue incrementing. 21. Internal linkage means the identifier can only be used in the file it's defined in. well, yeah. If I make a const variable in a CP file, other files can't access it unless I make it extern const qualified. If I make a function static, the same is true. Global variables are global non-const variables, and functions are both have external linkage by default, but static const expression can change that. 22. We'll do it. Okay. All even numbers from 2 to 20 inclusive. Okay. Let's do 4. Current num is starting at 2. 2. While current num is less than 2, or is less than or equal to 20. Increment, or current num plus equals 2. Increment by 2. Current num, oops. We'll just do the whole thing. Fuck it. Okay, for current num starts at 2. Current num is less than or equal to 20. Current num equals 2. Yeah, that's not it. Yeah, plus equals 2. So we we're updating it to be 2 plus whatever it is. Yep, cool. Current num. Cool. 2 to 20. Easy enough. 3. If you forget to increment the loop variable, assuming the loop variable, the condition divides to true, then we have then we get an infinite loop because we never increment the loop variable. It never reaches a value where the loop stops executing. Since the condition is stuck true, just like a while true loop. Positive numbers. Oh, fuck. Enter positive numbers until they enter 0 or negative. Enter positive numbers until 0 or negative number. Then print sum of all positive numbers. Okay. So we have a function that So we get a variable and we okay. So we could have a function that gets an integer, and then we have another function called like play game. And the game is they do this. They put in numbers until they put a 0 or a minus, like an Easter egg or something, where you're doing guesses until you finally get the right answer. In this case, negative and 0 are the right answers. And then at the end, it gives you all the points and all the shit from all the missed tries or something like that. So in this case, we have another function that calls get within a do while loop maybe. So do some variable equals the get number. And then maybe we have a stat or another variable. So we have one variable and we call the get number, get int, and assign it to another. And then we assign the first value to be itself plus the new one, because we can't track it within one variable, because whenever we get the input, we extract it, it would replace whatever the variable has, so we need two variables. Excuse me. And there's no like extraction equals or extraction plus equals thing. So there's no way to just add whatever we extract to it, I don't think. So not without operator overloading, I think. So, and I don't know how to do that. So we get a number. So within this loop, we do this and we get a number, we set it, and then so we have a number. I'm trying to see. So we get a number. And then we assign another number to be itself plus that number. And then if that number, if the most recent number is 0 or negative, or 0 is less than or equal to 0, then we print the current or the sum number. And then while the sum number so we could get the number first. I think we have to get the number first and then have an end case where if they enter 0 or a number less than 0 in the beginning, we just say, okay, 0, no number. Or the sum of all the positive numbers. Or say no positive numbers entered. It'll output. And then we have a while loop that says, hey, if that number is positive, then I feel like I want it all within the loop though. Do while, and then if it's 0, I think we want to do while. And then the while condition is the number in the loop. Let me do that. So let me say int get int. Oops. We say enter an int user int, value initialized to 0, standard character input, extract to user int, return user int. It's fine. We can handle extraneous input and other stuff later, not a big deal right now. And then we could say void play game. Okay, we say do int recent int, or do int I think this guy needs to be created outside, so we say int sum number, or int sum is 0 at first, and then we say int recent num is get int, and then we say if do this int and then we print the sum. And if sum is 0, okay. We could do if recent num is 0 and sum is 0, then output no positive numbers entered. And return. Otherwise, we could say, so we'll check that. So we get the number, and then we say, sum plus equals recent num and then we so we could say, actually, that wouldn't work right there, because we would start, and well, if that was 0, sum would be 0, or hold on. So in this case, we would start it, sum would be 0 by default. If they entered 0, then okay, this could work, but so we'll do this, and then we'll just say sum plus equals recent num, and then if recent num is 0, if sum is 0, no positive numbers entered, ending early, and then return. If it's 0, if the sum isn't 0, okay, we do this, and then we say if recent num is 0, output sum of positive numbers, sum, and then return. Oops. Oh, and then we could just say while true. So we say there's a sum. I wonder how that works if it's static in a while loop, because it probably gets deleted then still. So if we say there's a sum, and then we get a recent number, and then we add that to whatever sum is. If the recent number is 0, then that either means that end game update sum store total positive numbers, or update positive number total. User enters positive numbers until 0 or negative number. Then function prints sum of positive numbers of entered positive numbers. So we got the sum. We say there's this recent number, so we get a number from the user. Get num from user. Update positive number total. Excuse me, positive number sum. And they do this until it's finally 0. And then once it is 0, either if the sum is 0, they never entered anything. User never entered positive number if sum is still 0. Or user entered positive numbers, so print sum. Okay. Oh, we never outputted anything. Okay, so we'll say get int. Yo. Oh, we're not calling it. Good. Play a game. Internet 5, 3, 6, 0. Okay. 8 plus 6 is 14. 0. Negative 7. Oh, oops. It needs to be if recent number is less than or equal to negative 1. So we say negative 4. Oh, hold on. If it is less than or equal to this, sum of positive numbers. Oh, so we only want to sum it if it's positive. If recent num, recent num is greater than 0, we'll do that. So we could say negative 4. That's less than this. We say, oh, hold on. We say negative 4. It wasn't added, so we say no positive numbers entered. So we could say 4, 2, and 5. Negative big ass number, and it's 12. And then 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. It's probably like 13 or 11 now, maybe. And we say negative 3, 10. Cool. We could say 1, negative 1. Say 0. Say negative 1. Okay, cool. Seems good to me. Bop. Syntax errors are like grammar errors. They are a misuse of the language, of the missive of C++ language, and the compiler and language, which the compiler will create an error for, and IDEs will often flag somehow. Like using standard character output. Where using the operator this insert extraction instead of operator insertion for character output. We don't want to extract from the output buffer. Same with forgetting a semicolon. Same with semantic logical. Here's our errors of meaning, where the compiler may generate an error or a warning, but might not, or may generate a warning, but the code will probably execute just not how we want, because we misinterpreted the meaning, or misinterpreted what would happen. Like having a condition use operator assignment instead of operator, operator assignment instead of operator equivalence, where the right operand will be assigned to the left instead of checking for equivalence. That equates to a, probably equates to a to true. Well, it doesn't necessarily, but it could. It's likely. Same with another semantic error, like what? An off by one error, which the compiler won't care about. When we're using this instead of this, or this instead of this. How I would test a function that calculates a factorial. So I'd probably have a function that would test it. I would have a function that tests the function. And it would call it with some numbers that have set values. And it would say, if the call with this parameter is this known value, then it is true. I would make a Boolean returning function so I know whether the test passed or not. That calls the factorial obtaining function with a set of known multiple times with specific values. Each time returns whether, so we could say call it with 3 if the call 3 is whatever 3. So I'd probably have a namespace for the different known values, maybe or maybe not, and would have a Boolean returning function that calls the factorial obtaining function. I have logic saying, excuse me, if get factorial 3 is factorial 3 answer equals factorial test factorial 3 answer return true. That way I can get update a tracker variable to be true. Oh, well, actually I could have, would I want to switch fall through? No. If any of the calls and sample of it and test right. True if to be false if any of the tests return false, and to return true if none return false. Should be evaluate, not return. Assertions are a shortcut to outputting an error message and using standard abort. Instead, we assert condition and description of error, and if the assert condition is false at runtime, standard abort runs, saying the line or saying the file, line, and condition, which includes our quote that describes the error. Helpful way to stop the program, to examine the call stack when an error comes up. Also good to use an assert for unimplemented features. So if your program travels that unimplemented branch, the assert clarifies, yo, haven't implemented this yet. Better than doing a comment and forgetting about it. A program that reads integers until -1. Oh, that's interesting. Oh, we could say so there's a variable. So there's min and there's max. Min variable, max variable, recent number. If recent or if recent is less than min, assign min the recent. If recent is less than or is greater than max, assign max that value. And then just output those at the end until, and then while true, and then once they do that, return. Okay, so we could do main include IOStream, need standard character input and standard character output. Int get int. Oops. Standard character output. Prompt the user. Enter int. Int user int. Value initialized to 0. Standard character input. Extract to user int. Return user int. Void play game. We'll do while true. We're gonna say min max. Do I need 3? int max, int min. I think I do. Int recent num is get int, oops, not the address, that, if recent num is greater than or equal to max. Max is now recent num. If recent num is less than or equal to min, min is now recent num. If recent num is -1, standard character output, min, oops, and that, max, oops. Okay. Oops. And then it's forever. And then return. Oops. Didn't prompt the user. Didn't call the game. Fuck. Play game. Okay. 5, 100, -3, -100, -1. Minimum and maximum are -100 and 100. We'll try it again. That worked. Bro, what happened? There's no loop going on, huh? No, it keeps going. Why'd it crash? What happened? Oh, and I don't have my alarm going till 7. I was starting to get the heart rate going up there. Int min and max, we need these guys to persist. Store min and max values needs to persist outside the loop. User enters values or ints until -1, then prints min and max ints entered before -1. Excluding -1. Well, if it's less than or equal to min, and recent num is not -1, please. That way it doesn't assign -1. So say 45, -2343, 3, 6, and -1. Minimum is -2343 and 5. Cool. What if we say 1, 0, -1? Minimum is still 0 and max. Cool. That works. Bonus. Bop. There's no way it understood that so fast. Oh my god. Even without going on the internet. This is cool. So we use it once to get the quiz, and then I do a response. It just so happens that I did 2 quiz prompts earlier and they were shit. So I did it here. I did one and then I corrected it and then it was trash. And then I did the last one here that was good because it needs to access the internet to get access to learncpp.com, which this one did. And then the last one, it responds instantly because it doesn't have access. It's not pro anymore. It can't do the online search. And it probably doesn't think as long. So it just responds instantly, but it's still fast enough to do it. That's crazy. Okay, let's study this real quick, and then I'm going to bed. Correct. Interpreters execute code line by line, translating each statement to machine code or an intermediate form at runtime. Each statement, line by line. Oh my god. Okay. Sounds like that's correct. Okay. Each statement. This line, boom, ran it. Either translating it to machine code at runtime. So there's no package it, and then run the package, it is like package piece, package piece, package piece, package piece, package piece. It's like cutting off and cutting off and selling the pig's ear, and then his nose, and then his mouth, instead of just whole thing, package, 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 ship it all. It's like selling each piece, like packaging and selling each piece one day at a time, instead of taking one day to cut them all up into all the pieces, package them all up, and then sell it all at once. Interesting. The interpreter is the middleman to translate the shit. Okay. So CPUs still only execute machine code. It's just that we're either converting all of it early by compilation, or we're doing it as a middleman, piece by piece. And the interpreter and the CPU are like, interpreter's like, yo, this is this now. The CPU is saying, cool. And then he's like, yo, next. Interesting. Main. Entry point and starts the call stack, including header files. Cool. Ah, motherfucker. Yo. Okay. I guess I fucked up, maybe. Alright, well. Jesus. Cool. Yes, headers provide declarations so it knows about them. Yep. Declarations are the function's signature, the prototype, no body. Yes. And then the function body, the implementation. Include copies the contents. Yes. Square, cool. When the program tries to... Wait, motherfucker, what? A segmentation fault is when a program tries to access memory it doesn't have permission to use? How does that even work? Dereferencing a null or dangling pointer. Using memory. So if we allocate memory and then we free the memory, don't we just get garbage? I guess we don't get garbage values. We get garbage values when we have a variable that we can access in memory, but the values are wonk. But when we try and access other stuff that we haven't put a block in, it's like setting a house up on terrain that you haven't zoned off and gotten prepared. It's like, yo, you're gonna fall. You're gonna fucking have a fault. You're gonna fall through the fucking crust of the earth. You gotta lock the shit down first, get everything there, a pointer to it. Cool, good. We can't just do it and start poking around in random memory. Okay. Step into. Wait. Oh, these are commands. Step into, step over, breakpoints, and continues. Oh, okay, because we go to one breakpoint and then we say, okay, continue to the next breakpoint. Cool. Excuse me. Okay. Well. Yeah. Yeah. Size of type. Motherfucker. LL or LL. Oh. So long is LL. 4 LL. 4 LL. Okay. Noted. Well, I was like halfway there. So, name. Yep. Yes, increments evaluates, evaluates the increments. Yes, precedence. Yep. Remainder, assert. Yeah. Correct. Yeah, end of the block. It's a better way of saying it. End of the block. Static persistent cost, retain the value. Internal is only within this translation unit versus external is elsewhere. Can't access it if it's internal. If numbers cool. Infinite loop. Yeah, if we don't increment it, we're gonna get an infinite, buddy. Sum the positive numbers. Good use of a helper function in a loop. Oof. Oof. That one was interesting. I liked that one. Syntax versus logic error. Yeah. You're having issues with the Spanish versus saying the things that are just kind of wrong. I mean, we hear you. It's not like literally wrong. It's just the meanings are, the words are choppy and not what you think. You're saying talking about a sexy dog when you mean a sexy girl. You're like, come on, bro. All right. Testing factorial function. Good. Yeah. You have a test that harnesses that calls a function with known inputs and compare. Yeah. Motherfucker. test harness. Yeah, it's exactly what I fucking said, motherfucker. Call a function, and it says, yo, blah, 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 blah. Well, I guess you could have another function that this function calls the either way, but calls the function with known inputs. I'd rather them just be in the namespace, and then we have one function that we call as the test, and then it says, hey, this namespace compared to the value. This. Or you could call a function and pass it the number and pass it the value, and then have another function that calls that one. So you call this one, and you call these with the proper values, but you end up still getting the same thing where you're updating the two. Maybe it's better, but I don't think so. Okay, assertions, yeah, we catch them earlier. Yeah. Well, yeah. Yeah, I mean, you gotta stop the fucking file so you don't just, so the outputs of the errors don't get flooded or hidden by other outputs. I want to make sure to actually stop the program and do it in a quick and easy enough way. Bonus min max finder. Oh yeah. Well, what? Bro. If all user inputs are negative and 0. What? Wow, that's some booty code right there. So it starts at this, and we say, if this is greater than it, I guess we'd say we could just assign it to be as long as it isn't -1. I mean, we could first assign it to be that. That's the min and the max. So we assign min and max to be 0. And then we get int, and then we say, at first, we assign that to be the min and the max. And then subsequently, we say, comparing it to the previous one. So we could say, max is recent num, min is recent num. Like, do we do this just for like the initial case? I mean, we could do that. We do this one time. Oh, oops. Int max, int min is recent num. So we first get recent num. But then right here, we're not checking for 0. So if we entered 0 right here, it wouldn't be good. Whatever, it's fine. I'll look at it more tomorrow. I gotta go to bed. It's time.